Okay, so we're going to need to refactor some of the classes we did. Um, Again, I'm doing this refactoring because if you want, you can get to this point in the tutorial, okay? And you don't need to use more complex logic that maybe makes no sense for making these very basic things. Okay, so that's why we are going to need to refactor, because now we are going to make something a little more interesting. Okay, so first of all, I'm going to change this set locked. Okay, I'm going to remove this. Well, actually, let's change name and uh, let's call it capture by object. Well, I'm not sure if the name is good enough. It's just I'm just trying to say that some object that is transformed in Unity uh, is locking it. Okay, so locked is true, and now we are going to also save this transform as an object to look at. Okay, so object to look at is equal to the object. Okay, so now we have the information in the smartphone about what object we want to keep looking at. Okay, and well, we still need a method for releasing public but release the smartphone. Okay, and well, we just need to set locked as false. This was called here in interactive, so I know I need to, instead of set locked false, I will set release, and here instead of set locked true, it is capture by object this transform. Okay, and now in the smartphone we are going to change this. So we are not going to continue rotating the phone. Actually, we are going to say, okay, rotate the phone only if the smartphone is not locked. Okay, if it is, then simply get the transform, it is the smartphone, and look at the object to look at. Makes sense? Okay, so I just going to add this here just for clarity. Okay, I think that should be enough to make that work. So let's test it. Well, maybe it won't be very obvious for you, but as you see, oh, I lost it. Okay, let's try again. Um, what I was saying is, as you see, I don't need to, well, what you see is actually I'm always pointing to the cube, and well, that's basically because the cube is capturing the smartphone, and now I can just stop pointing at it, just keep using it, and it works fine. Okay, and it follows the cube. Well, it already worked fine, right? Now it follows the cube, and it looks much better because it gives more feedback to the user to know what he is acting, because I mean in which object he's acting, or he or she is acting, because if you just have the pointer locked but the user can still point to any other places, it could be confusing. Okay, but now there's some tricky part in here. If if you get the camera and actually rotate it, and let's say I put it in here. I'm just showing you what is going to happen if we keep the code as we have it now. What's going to happen once we can move toward the scene? Sorry, move through the scene, and it is that right now I'm going to make a, a movement, a scroll gesture from left to right. Okay, that was not left to right. What happened? Well, it was left to right if you are seeing the scene from this point. That is the um the 0, 0, 0 orientation, right, for the camera. So the moving the cube as we were doing is not quite correct, and it has a very simple fix. So actually, let me just keep that there, but let's go and check the interactive class. And the problem is here. We are just sending scroll X and scroll Y directly as forces in the world, in the scene. Okay. So now what we can do to fix that is make a vector with the force. Okay. If we multiply a vector, uh, oh, this is not a vector. This is a float value that tells us how much the user has scrolled in X, but we can multiply it by multiply it with by a vector that is the camera main transform. Okay, right, the right side of the camera. We are saying whatever is in the scroll X, I'm going to consider it to the right side of the camera, and we are going to this is a three-dimensional force, so we can also include here the scroll Y multiplied by camera main transform forward. Okay, so for the scrolling in the, the vertical scrolling just in your smartphone, we are going to transmit it um, towards or the direction you are looking at with the camera. Okay, and well, finally, instead of putting this here, we're going to call force directly. Okay, that I wanted to show that, and I wanted to make that mistake because probably if you are new using Muvslide, you could face that, and for some people it's not very clear how to fix it. Okay, so now I'm going to scroll from left to right, and it went fine. Perfect. Great. So now we have this smartphone. We can interact with the cube, and we can also, well, we know that we can move through the scene and it will work fine. But there's something that it's missing, and it's accelerating the smartphone with the accelerometer data. So the movement the user is doing feels more natural. Okay, actually, it's not going to help much in the interaction or make some. Well, it will make a little difference because it will be a little more intuitive for the people. But okay, this is actually a little more tricky. Using the acceleration. So we are going to need to add a new object here, a new empty object called to accelerate. Okay, and I'm going to put this two inside, all these three inside of it. Okay, and this is a tricky part of using the accelerometer, and I'm going to explain you why. The the accelerometer data, the axes you get, they are relative to the smartphone orientation. So if you rotate the smartphone and make a movement from I don't know, from left to right, it's going to consider the axis as moving. Let's say, well, maybe this could help actually. Uh, if I get this and rotate the smartphone, the axis in the smartphone will be something like this. They won't uh, be aligned to the Unity world anymore. Okay, so this smartphone here, this subject smartphone, is the one that has the script and that the one we are rotating. So if we accelerate a child of it, it will already have the rotation from the smartphone, so we can send the acceleration information directly to here without doing any other transformation on the data, and it will work fine. Okay. uh, if you didn't follow me exactly on this, because I know it's not quite clear, you can just try it. Uh, once we have this complete, we can pull this out of the smartphone and try to accelerate it and rotate the smartphone, and you will see what I'm talking about. Okay, if you move the smartphone at the same time you have it rotated, it won't move very well. Okay, so but okay, we have this to accelerate object here, and now we need a script for it. Okay, and it's going to be called accelerate smartphone. Okay, and let's pull it here. Perfect. Okay, so let's set it. Yep. Okay, so here we know we are going to need the acceleration. So for it, we are going to need the Muvslide input again. Muvslide input. Yep, using. Okay, Muvslide input. And well, what I'm going to do is we are going to move the smartphone with the acceleration, and then automatically it will go back to the original position it had. Okay, because the accelerometer data can't give you positional tracking. So you, for example, you can go in a room and expect the accelerometer to tell you exactly where you are. So we are just going to simulate that we are tracking the user actual hand movement, but we are just reading the accelerometer data. Okay, and I'm telling you that because I'm going to create this vector here called original position. Okay, so we can return the smartphone to the original position, and actually we are going to save it here as transform local position. Okay, I'm using local position and not just position, because as I said, this object accelerated smartphone is a child of the smartphone that is rotated. So it is important to use the local position so it moves uh, depending on the orientation the smartphone already has. Okay, and well, I'm going to put this method to set Muvslide input, so we can provide a Muvslide input object to the to this instance. Muvslide input. Okay. You can make this in different ways. For example, we know that a smartphone is the parent of the accelerated smartphone, so we could try to find the smartphone in the in the parent's objects and get component from parent. But well, I just didn't want to do that because I didn't want to add this um, direct dependency between the classes. But it's not like one is better than the other, or maybe it is. This is just clearer for me. Okay, set Muvslide input, so we can call that later. And well, now we are going to, I'm going to remove this. I'm going to create a method called react to acceleration. So I'm going to get a cell, let's call it just a cell, from acceleration in each axis, similar to the orientation, using Muvslide input get acceleration. Okay, and as you see here, the values correspond to the acceleration x, y, and z in that order. Okay, and for clarity, I'm going to put it here, x, y, and z. Okay, and actually the acceleration, we need to change the sign as well, because well, it is a little more related on how accelerometers work. Again, you can try this out and see how it works for you, doing some different um, well, not using this, and you will see how it behaves. Okay, anyway, I'm going to keep coding. So I'm going to create this new vector called new position. Okay, because we are going to change the position of the smartphone, and it will be the original position in x plus the x we just received. Okay, and same for y, and the same z. Okay, and now we just need to move the local position of this object accelerated smartphone to this new position. And what is going to happen is that it is going to move to the original position if you stop sending acceleration information. It's going to automatically go back to the original position as these values get closer to 0. Right? It's quite simple actually. And well, in order to use all this, let's go to the smartphone class. And again, it could be different here, but I'm going to declare the accelerated smartphone object here to detect the part to accelerate. Okay, and in the start method, I'm going to also add here part to accelerate is the component in children accelerate smartphone. So so on second thought, it is very similar to what I said I didn't want to do here, to call the Muvslide input. But anyway, this is more Unity than Muvslide. So um, set Muvslide input, and let's say Muvslide input. So I'm um, the final objective of this is showing you how to make this VR controller with Muvslide, right? So if you think of any better ways to make the Unity part, actually you can let me know, and it will help me as well to improve my Unity skills, of course. Okay, so what I did is I got the part to accelerate that I know is in the children of the smartphone and set the Muvslide input object there. Okay, and now in rotate phone we are calling this well, sorry, in update we have this is new motion available, and is new motion available is, as you see here, well, below the cursor, it includes orientation and acceleration information. So the thing with calling these methods, we have many is new. Okay, I'm just trying to show you. Is new playing, is new motion, is new scroll. These methods, once you call is new motion available, if it returns true, and if you immediately call again is new motion available, then it will return false. Okay, because once you call this method, Muvslide API will say, okay, I told you there is new information. So I'm assuming you are going to go and check what that information is. And if you ask me again if there is new information, I'm going to tell you no, because I already told you about the new information I had. Okay? So I can't just go and say here again is new motion information available, because it will always be false. Okay? Um, so because of that, I'm going to put together the rotate phone, the rotate and the acceleration. Okay. So actually, I'm going to rename this. Um, yeah, I'm going to rename this to move phone. Okay. And now here it is called move phone. So now we have already the part for rotate, and let's just add as well the part to accelerate. That's very simple. That is part to accelerate react to acceleration, because once when we call move phone, we know there is new motion available. Okay, so we just need to say, hey, react to the acceleration, and the react to acceleration will say, okay, Muvslide input, give me the acceleration. Okay, so it's very simple. um, and now let's see how it behaves. Okay, 1 second. There we are. So I'm moving my hand slightly, and you see a lot of movement, and actually it's kind of shaky. So it's not very nice. So what we can do for fixing that? Well, we have this um, Kalman filter class. Okay, so you can read more about it here, but let's go directly to it, and we are going to change the filter values for the acceleration. The Muvslide input has two Kalman filters, one for the orientation and one for the acceleration. Okay, so now the orientation was working fine with the default values, but the acceleration wasn't. Okay, so let's change that.